At 2025 level mechanics essay problem. A fire has taken place on an upper floor of a residential building. Part A, as shown in figure 1, a firefighter uses a fire hose to detect a stream of water at the burning floor to extinguish the flame. The nozzle of the hose is at 1 meter, height 1 meter above the ground and 10 meter horizontal away from the building. The stream of water is to be targeted at a height of 6 meters above the ground. The nozzle makes an angle 45 degrees with horizontal. The figure is not drawn to scale. Part 1. Calculate the initial speed V0 of water stream ejecting from the nozzle should have to reach the target. Neglect the air resistance. Take root 2 equals 1.4. We know that horizontal displacement from ejecting point to vertical building is 6 meters and is ejected angle theta. It is 45 degrees. Then we can find time to move from A to B. For the water flow, we can apply horizontally A to B, S equals ut. We know that when considering projectile motion, horizontal component is a uniform velocity motion. Then distance 6 meters. They have given ejecting velocity V0, then horizontal velocity component V0 cos 45. I am trying to find the time. Then we can get time is 6 divided by V0 cos 45. Now we can apply, it is gap between ejecting point to building is 10 meters. Then S value is 10 meters. 10 divided by V0 cos 45. And they have given total vertical height of the building 6 meters. But there is a 1 meter height below the ejecting point. Therefore, we can get this part is 5 meters. Then we can apply vertically from A to B. A to B vertically. We can apply S equals ut plus half at square. Now vertical height is 5 meters. Initial vertical velocity V0 sin 45. Time is this value. We can substitute 10 divided by V0 cos 45 plus half into vertical acceleration is equal to the gravitational acceleration. But it is in downward direction. We are applying equation in upward direction. Therefore, we have to substitute minus 10. T squared. Again, we have to substitute the square of this term. 10 squared 100 divided by V0 cos 45 squared. We can substitute V0 squared cos squared 45. Now we have to simplify this expression. This equation, we can solve this equation and we can find the V value. I will solve it. 5 equals, we can cancel out V0 and V0. We know that sin 45 value is equal to the cos 45 value. It is 1 over root 2. Then we can cancel out sin 45 and cos 45. Then value of second term is plus 10 Then we have to get plus into minus minus. We can cancel out 2 and 10. 2 divided by 2, 1. 10 divided by 2, 5. 5 into 100, 500. Divide by V naught squared, cos squared 45. Cos 45 is 1 over root 2. We can apply square term, half. Then I will bring minus term to the left hand side. It is 500. Divide by V naught squared. We can bring these 2 to the numerator. 10 minus 5, 5. Now I will cancel out 5 and 500. It is 100 times 2 equals V naught squared. Then V naught value is square root of 100 into 2. Square root of 110 multiplied by root 2 value is given in the question as 1.4. Then we can find V naught by multiplying 10 into 1.4, 14 meters per second. Then part 2, the initial cross-sectional area of the hose is twice that of nozzle outlet. Calculate the speed V1 of water inside the hose end before the nozzle. Assume that water is incompressible. This one is A part 1. Now we are solving part 2. When considering hose, there are two parts. This one is hose and this one is nozzle. They have given area of nozzle. Area of hose is twice the area of nozzle outlet. It means we can get, if the area of nozzle outlet is A, area of hose is 2A. We know that this ejecting velocity is 14. And we have to find the velocity of water inside the hose. Then we can apply A1 V1 equals A2 V2 continuity equation. A1 area of hose 2A. V1 means velocity in the hose. I will get it as V. A2 is A. V2 is 14. Then we can cancel out A and A. We can find the value 14 divided by 2, 7 meters per second. Then part 3, if the pressure of water inside the hose before the nozzle is higher than the atmospheric pressure by a value of delta P. Calculate the value delta P. Assume that flow is steady and water is non-viscous. Neglect the vertical height between nozzle outlet and hose end just before the nozzle. They have given density of water is 1000. Now we can apply Bernoulli's principle. When applying Bernoulli's principle, I will draw a diagram to mark corresponding points. We know that velocity at this pace 14 meters per second. Velocity at this pace 7 meters per second. Then we can apply Bernoulli's principle between point X and point Y. We can write P plus half rho V squared plus H rho G at point X should be equals to P plus half rho V squared plus H rho G at point Y. Then we can substitute values, but they have given that this H value is negligible. It means this height is negligible. It means there is no height difference between point X and point Y. Therefore, we can cancel out H rho G term. There is the same height from potential energy 0 level to point X and potential energy 0 level to point Y. Then I will get pressure at X Px plus half density of water 1000, velocity at this place 7 squared 49 equals pressure at Y Py plus half density of water 1000, velocity at Y is 14 squared 196. Then we can subject pressure difference Px minus Py, half 1000 common factors 196 minus 49, divide by 2 1, divide by 2 500, 500 multiplied by 16 minus 9 5, so 16 minus 9 7, 8 minus 4 4, 147 into 500. I will put 2 zeros at the end of the answer. 5 into 7 35, 3 remaining, 5 into 4 20, plus 3 23, 2 remaining, 5 into 1 5 plus 2 7. We can write it 7.35 into 10 to the power 4 Pascal. They have given pressure difference as delta P. Then part 4. The internal diameter of nozzle outlet is 2 centimeters. Calculate the volume flow rate Q of the water jet traveling the nozzle, leaving the nozzle. Volume flow rate means AV product, cross-sectional area into velocity. Volume flow rate is cross-sectional area into velocity. I will get velocity. I will get area. They have given diameter of nozzle outlet is 2 centimeters. Therefore, we have to get that it is a circular outlet. 5r squared multiplied by velocity at outlet is 14. We have found it in part 1. Then they have given phi value as 3. 3 multiplied by diameter 2 centimeters, radius 1 centimeter. I will convert it to meters. 1 into 10 to the power minus 2 squared into 14. 3 into 14, 3 into 4, 12, 1 remaining. 3 into 1, 3 plus 1, 4. 42 into 10 to the power minus 4, 4.2 into 10 to the power minus 3 cubic meters per second. Unit of flow rate, cubic meters per second. Then part B. A firefighter expects to reach the burning floor by climbing up along a ladder as shown in the figure 2. A uniform ladder of length L and mass capital M rests on rough ground at A with its top end against the smooth wall at B. The ladder makes an angle theta equals 60 degrees with the ground. The mass of the firefighter is simple M. Part 1. Assume that the firefighter is standing upright on the ladder at the distance x from the A. Draw the free body diagram of the ladder and mark all forces acting on the ladder, taking normal reaction forces at A and B and frictional force at A acting on the ladder RA, RB and F respectively. Draw uniform rod for ladder. Now we have to draw the free body diagram of ladder. Then we have to draw only ladder. When considering ladder, B is a smooth surface. Therefore, there is only a reaction, RB. And A is a rough surface. A is at this point, rough. Therefore, we have to mark reaction and frictional force against the motion. Ladder is trying to slip in this direction. Therefore, we have to mark frictional force in opposite direction. And weight of ladder, capital Mg, it is at the midpoint, and at x distance we have to mark weight of firefighter. There are 1, 2, 3, 4, 5 forces. We have to mark all 5 forces. Then B part 2. If the coefficient of static friction between the ground and ladder is mu, by resolving forces and taking the moment around A, derive an expression for the maximum distance x max in terms of capital M, simple M, L and mu that the firefighter can climb before the ladder begin to slip. Then when slipping, then it is trying to slip. We know that frictional force is acting on in this direction. I will mark capital Mg, simple Mg. Mg is at, simple Mg is at x distance. This distance is x. Then we can write frictional force. F equals mu r. Mu Ra, normal reaction at A. Then I will get vertical equilibrium. There are 2 forces in downward direction and there is only one upward force. We can write upward force Ra should be equals sum of downward forces capital Mg plus simple Mg. Then we can get torque around this point, it means point A. I will get torque around point A. Clockwise torque should be equals to counterclockwise torque around point A. When getting clockwise torque, there is only one force acting on the object is goes to clockwise torque. It is Rb. Rb multiplied by, we can write, if this angle is theta, this angle also theta, we have to multiply by perpendicular height. Length of ladder is capital L, then we can write this height is L sin theta. L sin theta. Rb L sin theta should be equals to, there are 2 forces goes to counterclockwise torque, capital Mg and simple Mg. When getting torque due to capital Mg, force capital Mg, we have to get distance from point A to action line of capital Mg. It means this one. We know that this part is capital L over 2. It is midpoint of ladder. Then this distance is L divided by 2 cos theta, adjacent side, plus second force, simple Mg, mass of weight of firefighter, multiplied by x cos theta. For the sliding condition, we know that Rb in this direction should be equals to F in opposite direction. Therefore, we can substitute Rb value as mu Ra. Then we can write mu Ra for the Rb value, L sin theta equals capital Mg L divided by 2 cos theta plus Mg x cos theta. For this condition, it means if frictional force is equal to Rb and if the frictional force is maximum value, it means limiting frictional force, we can write x is the maximum distance. Therefore, x max cos theta. Now we can divide all three terms by cos theta. Then mu r a L sin theta divided by cos theta is tan theta. Capital Mg L over 2 cos theta divided by cos theta 1. Simple Mg x max. Again cos theta divided by cos theta 1. Now we have to subject x max. Then we can write x max equals mu r a L tan theta minus capital Mg L over 2 divide by simple Mg. Then we can divide separately two terms Mg. And we can cancel out G and G in this one. Then we can obtain x max equals mu r a. We can substitute r a by using this relationship. Then mu capital M plus simple M G L tan theta divided by simple Mg plus ml over 2m. Again we can cancel out G and G in this term. Then x max value is mu m plus m L tan theta divided by simple M plus Mg divided by 2 simple M. It is the final relationship we can obtain. But they have given that theta value is 60. Therefore, you can substitute tan 60 for this one. I will substitute it. Then x max equals mu capital M plus simple M L tan 60 is root 3 divided by simple M plus this term capital Mg divided by 2 simple M. Capital M L divided by 2 simple M. In part 3, they have given values. If capital M equals 20 kilograms, simple M equals 70 kilograms, capital L equals 6 meters and mu value 0.3, calculate the value x max. Give your answer to the nearest integer. Take root 3 value as 1.7. Then we have to substitute given values to the equation obtained in part 2. We can write x max equals mu value 0.3. They have given capital M 7. It is the mass of ladder. It is given as 20 plus simple M 70. Capital L value 6 meters. Root 3 1.7 they have given it. Divide by simple M value 70 plus again capital M value 20. Capital L value 6 divide by 2 times simple M value 70. Now we have to simplify it. 0.3 20 plus 70 90 into 6 into 1.7 divide by 70 plus I will cancel out 0 and 0 then 2 and 2 6 divided by 7 0.60 divided by 7 856. I will get only to the first decimal place because of we have to get the answer to the nearest integer. 9 into 3 27. 1 decimal place. 6 into 7 42. 4 remaining. 6 into 1 6 plus 4 10. 1 decimal place. Divide by 7 plus 0.8. 10.2 multiply by 27. 2 into 7 14. 1 remaining. 7 into 1 0 0 plus 1 1. 7 into 1 7. 2 into 2 4. 2 into 0 0. 2 into 1 2. 4 5 7 2. 2754. We have to separate 2 decimal places. Divide by 7 plus 0.8. 27 divided by 7, 3. 6 remaining. 65 divided by 7, 9 plus 0.8. Then we can add it. 9 plus 8, 17, 1 remaining, 4.7. To the nearest integer we can get it 5 meters. Part 4. Firefighter place a special anti-slip mat under the ladder foot as A. Prevent the ladder from slipping. If the firefighter must reach the top of the ladder, find the minimum coefficient of static friction mu minimum between the mat and ladder. Must have using the expression derived in B part 2 above. Give your answer to the nearest 2 decimal places. Again we have to use same equation, but now we have to find the frictional coefficient mu value. Then I will write again part 4. You know that x max equals mu capital M plus simple M L root 3 divided by simple M. Not plus, it should be minus ml over simple M over 2. Then in previous calculation we have to subtract we have obtained 3.9 and 0.8. Then answer should be 3.1, 3 meters for the part 3. Then part 4. Now x max value is given as 6. Mu is the problem. 70 plus 20, 90. L value 6. Root 3 value 1.7. Divide by simple M 70. Mass of firefighter. Capital M 20. L 6. Divide by simple M 70 into 2. Again value of this one is 0.8. I will bring it to the right hand side. 6 plus 0.8 should be equals to this one. 9 into 6, 54 into 1.7 divided by 7 mu. Then we can subject mu 6.8 multiply by 7 divide by 54 into 1.7. And you can simplify it and obtain answer 0.52. In part C, as shown in figure 3, another firefighter uses a rope and pulley to go up and rescue a person. The pulley with radius 0.1 meter is fixed to the crane of the fire truck and light inextensible rope passes over it. The firefighter is attached to one end of the rope and the other end is pulled by constant force 960.5 by a motor in the fire truck. The mass of the firefighter with rescue basket is 680 kilograms. The pulley rotates freely and the rope does not slip on it. The moment of inertia of the pulley about rotational axis is 2.5 into 10 to the power 3. Determine the linear acceleration A of the firefighter. We can get tension of the rope and total weight, mass 80, we have to get mg, then 800. It is forces on rescue basket. Then we can apply F equals ma in upward direction. Upward force tension minus downward force 800 ma. It is the first equation. When considering pulley, there are two forces. Force given by the motor 960.5 and tension. Then we can use we can apply tau equals I alpha for the pulley. Torque is 960.5 force into radius 0.1. It is the supportive force to rotate. Opposite force, tension into 0.1. Force into perpendicular distance. Moment of inertia is given as 2.5 into 10 to the power 3. It is I value. We can apply alpha by using linear acceleration. A equals R alpha. Then R alpha. Radius 0.1. We have to substitute alpha by using this relationship. Then we can subject alpha. Alpha is A divided by R. Acceleration is same as the linear acceleration of rescue basket divided by radius 0.1. Now we have to find linear acceleration. Then I will get 960.5 into 0.1, 96.05 minus 0.1 tension. I will substitute tension by using this equation. It is ma plus 800. Mass 80 A plus 800. It is tension. (0.1) into tension equals, we can get this one, 2.5 into 10 to the power 4. I have divided by 0.1 into A. Then we have to find the value of A. I will remove brackets. 96.05 minus 0.1 into 88 A plus 80 equals 2.5 into 10 to the power 4. This one should be 10 to the power minus 3. We have given moment of inertia 2.5 into 10 to the power minus 3. Minus 3 divided by 0.1 means minus 2. Now I will subtract this one and this one. It is 16.05. This value 0.025 A plus 8A. 8.025 A equals 16.05. Then we can find acceleration 2 meters per square second. Then part 2, if the system starts from rest, calculate the angular speed omega and the rotational kinetic energy K for the pulley after 3 seconds. We can get angular acceleration. It is C part 2. C part 2. Angular acceleration is linear acceleration divided by radius. A equals R alpha. Then linear acceleration to radius 0.1, it is 20 radians per square second. RAD is minus 2. And we can apply omega 2 equals omega 1 plus alpha t. Omega 2 is the problem. Omega 1 0, it is initially at rest. Alpha this value 20 time 3 seconds. It is 60 radians per second. Then we have to calculate the rotational kinetic energy. When calculating rotational kinetic energy, we can write rotational kinetic energy is half I omega squared. Half I value 2.5 into 10 to the power minus 3. Omega squared 16 to 60, 3600. 2 divided by 2, 1800. And you can multiply it and you can obtain that rotational kinetic energy is 4.5 joule.